Welcome to the WION podcast. Today, we're diving into something pretty strange, actually. Mysterious rings have been found, but not where you'd expect, around a minor planet.
Exactly. And, finding rings around these smaller bodies is really quite new. We only know of a handful.
Right, it's not like Saturn or Jupiter. So the big question is, how? How does a small object like that hold on to rings?
Well, the star of this story really is Chariklo.
Chariklo, okay.
It's a minor planet, orbits out between Jupiter and Neptune. And it's tiny, maybe 250 kilometers across, something like that.
Wow, that is small on a planetary scale.
It really is. But here's the amazing part. It's the only centaur we know of.
And a centaur is?
Oh, right. It's one of those objects that's kind of a mix, a bit like an asteroid, a bit like a comet, icy and rocky. They hang out in the outer solar system.
Gotcha. So Chariklo is the only centaur known to have?
Not just a ring, but two. A double set.
Two rings, or else something that small. That's wild.
It is. It completely surprised everyone.
So, okay. How? What's the leading explanation for this? There must be something going on.
The best idea we have right now involves, well, something we haven't even seen directly.
Oh, intriguing.
The theory is there's a tiny moonlet orbiting Chariklo. Maybe only a kilometer across, something really small.
A little moon. Like a shepherd moon, but for a tiny planet.
Exactly like that. Think of it as this little gravitational influence, constantly sort of nudging the ring particles.
Keeping them in line.
Precisely. Keeping them confined, stopping them from just drifting away over time.
Okay, that starts to make sense. There's this concept, the Roche limit, right? Does that play a role?
It does, yeah. The Roche limit is basically the zone where tidal forces from the main body are strong enough to rip smaller things apart. And Chariklo's rings are sitting very close to that limit, which is interesting in itself.
So the moonlet's gravity would be crucial for keeping things stable right there on the edge.
That's the idea. Without that moonlet acting as a shepherd, the ring material would likely disperse or spread out.
Have people run simulations to test this?
Oh, yes. Researchers modeled what would happen to rings like Chariklo's without a moonlet. And just as you'd expect, the simulations show the rings would widen and fade over time. They wouldn't stay thin and distinct like we see them.
So the fact that the rings are thin and distinct is like indirect evidence for this hidden moon.
It's strong evidence, yes. It really bolsters the case. It's a bit of cosmic detective work,
That really is fascinating. A secret moon shaping these tiny, distant rings.
It is. And it tells us that maybe ring systems, or the conditions for them, might be more common around smaller bodies than we initially thought.
What about the rings themselves? Do we know what they're made of? Ice? Probably.
Ice is certainly a likely major component given where Chariklo is, but the exact composition, the size of the particles, how they interact, that's still pretty unclear.
And I guess it's hard to study something so small and far away.
Extremely hard. You really need a dedicated space mission to get up close looks, and Chariklo is just one of many distant objects. Direct observation is tough.
So we might not get a picture of this moonlet anytime soon, but we can infer it's there from the rings.
That's the current thinking. It's a really neat puzzle.
A hidden moon shaping the rings of a distant minor planet. It certainly captures the imagination. Stay tuned for more such intriguing stories to come.